In this video, we're going to verify the rank nullity theorem for a given linear transformation. So here I have a map from R4 to R3, and I've given it by saying what happens to the vector x, y, z, w. So the first thing we're going to want to do is write down the standard matrix for our linear transformation. And we'll compute the reduced row echelon form. So I've gone ahead and typed this into Wolfram Alpha. And that's what we get. I'm going to go ahead and circle our two pivots here. Right, now the rank nullity theorem says that if we take the rank, which is the dimension of the image, and the nullity, which is the dimension of the kernel, the sum of those two things should be the dimension of the domain. So looking at what's going on here, probably the rank is a little bit easier to see, the dimension of the image. So the image is spanned by the columns of our standard matrix. So if we were going to write down a basis for the image, we would simply take the columns that correspond to the pivot columns. So we have two pivot columns, so the rank is going to be 2. Now the nullity is the dimension of the kernel. So the kernel, remember, is all the things that get mapped to the 0 vector. So we would think about solving how to produce the 0 vector out of the image here. So it would be solving the homogeneous system where we augmented this with the 0 vector. And if we were trying to write down the basis of that homogeneous system, we would be looking for free variables, which would tell us what the dimension of that solution set is. So the free variables come from the non-pivot columns. So that would be the third and the fourth column. So we have two non-pivot columns. So this tells us that the nullity of T, the dimension of the kernel, is also 2. And all the rank nullity theorem is saying is that the number of pivot columns plus the number of non-pivot columns better give you the number of columns, right? The number of columns is the dimension of the domain because we have one column for every basis vector of the domain. So the rank nullity theorem here is saying that 2 plus 2 gives us 4 because 4 is the dimension of the domain.